Good morning everyone, welcome to this morning's workout. I've got 5 questions as usual, which I hope will keep your hand in during this difficult period we're all facing. My name's Stuart, I'm the ExamSolutions guy, if you haven't seen us before. And it's good to see so many of you coming back, and welcome to any of you that are new to these live streams. Okay, so what delights have we got today in our statistics workout? Well, I'm going to be doing Venn diagrams, bit of conditional probability, normal probability. We'll do some discrete probability distributions and some work on quartiles. That's just to name a few of the topics, okay? So this is the first one of the statistics workout, and I hope you get some value from it, and we'll move on from there, okay? Before we start, just like to say, is Michael on? Michael has been helping me over the previous workouts. I'm sure many of you have know that, but Michael from Air Maths Tuition, give us a thumbs up if you're out there, and he's going to tell us, or he's going to answer your questions as I talk through the questions that come up. Okay, so yeah, welcome Michael. I can see you've given us a thumbs up. Right, okay, so let's get cracking. It's going to take us about half an hour as usual. Okay, so give you your first question and I'll just talk you through it, okay? The reason why I've given you this. Okay, so what we've got here is a group of people that took part in a survey and were asked which colours they liked from the 3 choices. Red being the set R, blue being the set B, and green being the set given here as G. And I've got them then in this Venn diagram here. Now what I'd like to do this morning is just get some quick responses, because one of the things is that I find that quite a lot of people trip up on this particular type of question. So if you are ready to go, okay, little quick bit of mental arithmetic here, okay. And Michael, I know you're on. Can you make sure you don't answer any of these questions just at this stage, okay? I just want to see what the reaction is, okay? So here we go. First, I'm going to ask you guys how many liked, okay, this one here, just 2 colours. Just put your answer down very quickly. Just type it in. How many people liked just 2 colours? And we'll see what the answers come in as. Okay. How many like just 2 colours from the Venn diagram? Right, we're getting some answers coming in. Okay. Right, so we've seen another answer. We've got Rahima with 17, a lot of 13s coming in. And what about this one then? How many liked just 2 colours? Sorry, how many liked 2 colours? Okay, right, how many liked 2 colours? Go for that one, okay? So how many like 2 colours? Right, now we're getting 17 coming in. And you can see there's some answers here, 13 as well. But the majority of you seem to have got the idea here. It's a play on words, really, okay? So we'll quickly run through that, okay? So the answer to A, let's just put it up, yes, was the result of 7 plus 5 plus 1, which was 13, just 2 colours. But when it comes down to the question, which is how many liked 2 colours, okay, that does include the one in the middle here. Even though 4 people like 3 colours, they still nonetheless like 2 colours. Okay, so you need to count that one in. Anyway, I just thought I'd put that one past you because I quite often find that people trip up on that. Okay, just moving on very quickly, another one for you. How many took part in the survey? Okay, how many took part in the survey? Let's get the answer for that one. Okay. $59 we've got as one answer. Anybody else want to offer an answer? How many people took part in the survey? Got 38 coming through, 38s, and yes, 38 it is. Okay, I don't know how you got 59, Rahima. Maybe you might have been counting numbers twice over, but basically you've got to just add up all the individual numbers in each of the sections here. Okay, so it's 38. Bear that in mind because I'm going to do the same question again. We're going to carry on with it. Okay, and here it is again. And we're going to look at some probabilities. Now I know that some of you are doing AS, some of you are doing A level, so I've decided here to split this and do a question at each level. You might want to do both, okay? We've got these 2 questions. For AS, it's the probability of R union B complemented, okay? And for B, A-level students, the probability of B given that G has occurred. Okay, so give you a few moments, just come up with whatever you think the answers are for A and B. Can you state clearly though which answers you're giving? Okay, right, we have an answer from Rahima. I'd like exact fractions if possible. Okay, by the way, rather than decimals, make it a bit easier. Okay, so Rahima has 22 over 38 for part A. Anybody else going to offer up anything? Marcus coming in with 5/18. Which one's that for, Marcus? Okay, do make it clear if you can tell us which one you're trying to answer. James coming in with 16/38 for A. Jasmine 3/19 for A. So we are getting some differing answers here. For B, Christopher with 5/18. Okay, so good to see a lot of you out there having a go. That's the aim of this exercise. Okay, obviously it'd be nice if you get them right, but it's just having a go is the thing. All right, so I can see that some of you got the right answers. Obviously some of you haven't. So let's just run through this, okay? For answer A, it was 16 out of 38. And why was that? Okay, because R union B, okay, is everything in these 2 regions here, in the R and the B. That would be the 3, the 5, the 7, 4, 1 and 2. But we've got the dash here, the complement. What does that mean? Everything not in R union B. So that just leaves the 6 and the 10. A total of 16 out of everything. And I asked you in the earlier part how many people took part in the survey. So it was 38. And I've reduced it down to 8/19. Okay? Right. Okay, so next up, conditional probability. I'd like to do a lot more on this because later on in any of the workouts, but conditional probability always tends to give people a bit of a nightmare. When it comes to working with Venn diagrams though, it's dead easy. What we've got here is the probability of selecting or choosing, liking blue, given that you know people like green. Okay, so This is the number of people who like green. Okay. What we've got to do is look at how many of these like blue. It was the 4 and the 1. A total of 5 people out of all the people that like green. That is the answer. It's going to be 5 out of 18. Okay? The 7 plus 4 plus 1 and 6 gives us the 18. Okay? Now, some of you though might have approached this in a different way. There's the formula that you see in the formula books for conditional probability, the probability of A given B, the probability of one event given the other. It's the probability of both events happening, given as the probability of A intersecting with B, divided by the probability of the given event, B. Okay? And if we apply this here, if you were to use the formula, this is what would happen. It's a lot longer when you're using Venn diagrams. The probability of B intersected with G, okay, is going to be the total in here, the 4 and the 1, okay, a total of 5. We're dealing with probabilities, so it's 5 out of 38. Divided by the probability of green, liking green, that's going to be all of these people in here, 7, 4, 1 and 6. That gives a total of 18 out of 38. And you can see that if you multiply top and bottom by 38, you end up with 5/18. I always think this is too long when it comes to working with Venn diagrams. You should be able to just recognize it off the diagram. This type of method I tend to use when it comes to working with probability tree diagrams. More to do on that later on in the other workouts. Okay, so let's move on. Okay, 5 questions today, and we're going to look now at the next one. So this next one is about a random variable x. A random variable x has the following probability distribution function, and it's given by this formula here, okay, or equation I should say. And I've got an AS question where you've got to find out what the value of the constant k is. And I've got the A-level question, okay, work out E of x. If you're an A-level student, you should be going for both of these. So do say again which part you're going for in your answers in a moment, okay, when you put them up. Whether it's A or B that you're giving the answer for. Okay, if you're an A-level student, it'd be good though if you do work out, well, you've got to work out K anyway. All right, so let's have answers coming through. Okay, I can see some of you might not have covered this topic as such, and if you haven't, hopefully I'll give you a little insight into this as we work through. Okay, you can always go on my website examsolutions.net, check out the videos on this. Okay, we have an answer here. James has given us for part A, k is 1/29. Sarah has given us 1/29 k. I think you might have meant 1/29 is the value of k. Liana with 1/29 seems to be a popular answer, but is it the right answer? Anybody else going to give us a thumbs up on k being 1/29? Okay, well, while some of you guys out there might be working out E of x, I'm going to take you through working out k, because you're going to need it anyway for E of x. The answer is k is 1/29. Well done. I think that seems to be a good question, easy question for a lot of you. You all seem to be getting that one right. I'll show you what I've done. You don't necessarily have to draw up a probability distribution table, but if ever you are asked, this is what it would be. You've got your random variable x, takes on these discrete values 2, 3, 4 and 5, which I've given here, okay? And you use the small letter x for it. And then we're talking about the probability that our random variable x takes on any of these values. And when it's 2, you can see that we have to put 2 in here for x and we get 5k. Same when you put 3 in, you get 6k. When you put 4 through, be careful here, I purposely put the 2 there rather than just leave it as kx. So if you're rushing, you might have tripped up there, I don't know. But 2kx, okay? So when you put the 4 in, you're going to get 8k. Put the 5 in, you get 10k. What we should know is the sum of these probabilities will always total 1. So you've just got to make an equation for that. And if you do that, solve it, you should see k turns out to be 1/29. So great stuff there. I can see that was an easy question for you guys to do. Tends to be on most examination papers, you get questions like this where you're going to have to at least work out k. Okay, so E of x, what does E mean? It's the expected value of our random variable x. A lot of you might remember this as the mean, okay? The mean of a probability distribution, getting myself tongue-tied there, okay? It's what we would expect our values to be. Again, I've got tutorials on this on my website, how it's derived, okay? So, at the moment though, I'm assuming that you are familiar with this. So is anyone going to give us the expected value for x? Okay, the mean. Nobody coming in with an answer yet. Ah, we have one coming in. E of x from Liana. E of x, she reckons it's 110/29. Anybody else? By the way, there might be some delay here. I see these results coming up on the screen and it could be a little delay in mentioning them. So anybody else? Liana with 110/29 for E of x, the expected mean. Okay, let's carry on then, okay? Well done, Liana. You have definitely got the right answer there. 110/29. If you did convert it to a decimal, it would be 3.7931 and so on, okay? Right, very quickly then, this one, do try and learn this one up. This is the formula you tend to get generally in textbooks, sheets. Briefly, E of x, the expected mean, is to work out the sum of x times the probability that your random variable x takes on that observed value. Okay? In other words, what you've got to do is 2 times 5k plus 3 times 6k plus 4 times 8k plus 5 times 10k. Substitute your value of k in and you will find that when you've done that calculation, it comes out to 110k, but k we know is 1/29th. So multiply that with 110 and you get 110/29. So it could be then that a lot of you haven't necessarily covered this at school, college yet, okay? So, as I say, go on my statistics section on the website and ExamSolutions.net and you will see tutorials on this, okay? Right, let's move on, okay? Quickly move on. Number 3. What have we got here? Stem leaf diagram, okay? Where you've got this key here. 2 vertical slash 5 means 25. What I want you to do is find the median for A, quartile for B, okay, often known as Q1, upper quartile, Q2 for C, interquartile range for D, okay? So let's see how we get on with this one. Put your answers up, tell us which ones you get, okay? Right. Okay, so we're looking for the median first, okay? Let's see if we can get median. For A, we're getting the median as 4. Interesting. Okay, let's see if anybody else agrees. Okay. I think I might know why, Jasmine. You might have put A as 4. Take care. Okay. Sarah's coming in with the median Q2 as 4. Okay. Whilst others have got 34. I wonder why. Okay. Okay, so we've got the median seems to be coming in here now as 34 as a popular answer. It is 34. Okay, I know that if you put 4, the chances are you didn't look at the key. Okay, so now I see some of you giving me the lower quartile, Q1. That's coming in as 25 from some of you. I notice that we've got 44 for the upper quartile from the likes of Christopher. I can see they're streaming past me here, so I might have missed your name out. I'm sorry about that. And any takers for Q3? I can see some 44s coming through for part C. And part D, we're getting 19 for the interquartile range. Okay, well, I can see a lot of you are getting this right. Okay, so well done to you guys. And I'm going to just quickly run through this. Okay, so what we've got is we need to count up the observations. So if you count up the number in here, you'll find that there are 17. And so when it comes to finding the position of the median, remember that's the middle value. When you've got a discrete set of numbers, which we have here, 17, to get that middle position, add 1 on and divide by 2. So 17 add 1 divided by 2, that's 18 divided by 2, gives you your 9th value. That's the position of the median, it's not the median, okay? Now, that 9th value you can see I've circled, okay, in red. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's not 4, as I noticed some of you did, right, okay, 34, okay, according to the key. So, let's put that median in there. It's Q2, it follows that it's 34. So when you're finding the middle of a list of discrete observations, always add 1 to however many observations you've got and divide by 2. It's the easiest way, okay? And that brings me to this next point then, because when we're looking for the lower quartile, we're looking to the left in the lower part of the list here, to the left of the median. Finding a quarter of the way through the whole list is like finding halfway through the left-hand portion of the median. So, how many values have you got below the median? The median was the value, so you must have 8 values. So, if we're to find the middle of that list, add 1 to the 8, that's going to be 9. Divide by 2 is going to give you 4.5. So if you do that, the position of the lower quartile will be the 4.5 value. When that happens, you're looking at the mean of the 4th and 5th values. So you need to work out what those 4th and 5th values are. And you can see they are these 2 5s here. Okay? So is the lower quartile is the mean of the 4th and 5th values, which are 25 and 25, not 5 and 5, 25 and 25 divided by 2, which does give you 25. Okay? And when it comes to the upper quartile, you just need to come in from the 4.5 value from the top end. You can't do that, so you come in 5 values and 4 values from the top end. Okay? So if you do that, you'll get these 2 values here. 43 and 45. You're coming back to the 4.5th value, okay, which will be halfway between these two. So that means that Q3 will be the mean of 43 and 45, which is 44, okay? And when it comes to the interquartile range, remember the interquartile range is the upper quartile, Q3, minus the lower quartile, Q1. 44 minus 25, which is 19. Okay, so well done to you guys out there who got that right. Okay, now let's move on. Okay, that half an hour I said is pressing on. Got 2 more to go, and in this one, okay, this one I'm hoping that you've covered it. We've got here, Claire went to the hardware store and bought 6 light bulbs. Given the probability of a bulb being 40 is 1%, find the probability of at least 5 working. Okay, 5 of those light bulbs working. Give your answer to 4 decimal places. Now you might want to use your calculator. Well, you're going to have to use your calculator really for this one. So give us that answer to 4 decimal places. Okay, question 4 there. I might give you a few clues in a moment if you're struggling with this. Have you worked out what kind of distribution this is? Does anyone want to type that in at all? What kind of distribution? Okay. Anybody out there can tell us what distribution? No takers? Okay, well it's... Oh, all right, okay, yes, we've got some people coming in now. Good. It is a binomial distribution. All right, okay, so that should be a clue for a lot of you guys. So set up your binomial distribution. 2 parameters, n, the number of trials, okay, p, the probability of success, and you should be able to see your way through. All right, we've got an answer coming in. Jasmine, 0.0585 for Jasmine. Okay, anybody else? 0.9985 for Amy. Anyone else? Okay, another one, Sarah, 0.9985, 2 for 0.9985 at this stage then. Anybody else? 0.95, 0.9985, okay. Right, well, the answer is 0.9985. Well done to you guys, well done to Amy, got there first. All right, okay, let's just quickly take you through this one then. I have just given you this note here as a reminder. If x is distributed binomially, we have 2 parameters, n the number of trials, p the probability of success. You should be familiar with this formula. Okay, now many of you guys most probably would have used your calculator. I normally use a Casio Class Whiz and it's got the binomial distribution on it. I was going to bring this up on the screen this morning, but there was a slight technical issue. I won't go into that, but you can still work this out manually, and it's good to know where these problems have come from. Okay, let's just take you through it. To define your random variable, let x be the random variable number of faulty bulbs. Okay, that means that we have... Oh, I just realized, I think... no, it's okay, sorry. Number 40 bulbs, and we had 6 light bulbs, okay? So that's the number of trials, n, 6. And I've defined the probability of shall we say, success. Seems very strange, I know, having a faulty bulb as being successful, but P is 0.01, the 1% here, okay? The probability of getting a faulty bulb. So, when it comes to working out that we have a probability of at least 5 working, that's going to be the same as working out the probability that x is less than or equal to 1, that you get 1 or none being faulty, okay? So that's going to be that sum there. And all we need to do is enter these values into this formula if you haven't got the statistics function on your calculator. Okay, if you do put those values in, okay, this NCR 6 choose 0, 6 choose 1, okay, is used. Anything C0, okay, is 1. Anything C1 is that anything here, in this case 6. So you're going to have this calculation to work out, okay, and if you do it, you'll see you do get 0.9985 to 4 decimal places. As I said, you will be able to do this on a Casio ClassWiz, and I'm sure some other calculators out there. Do check out my website. I've got video tutorials on using the Casio ClassWiz to do the binomial distribution. Probabilities like this. As I said, I was going to bring it up this morning, but just had a technical issue there. So another time maybe, okay, for that one. Now, next up, okay, last question, very short question because we are running out of time, okay. Here we go. The rainfall in millimeters for each day in a particular week was these values here, okay. 2.6, 5.3, 2.4, 8.1, 0.0, 0.5, 1.6, and the mean amount of rainfall for the previous 21 days is 4.3 millimeters. Calculate, okay, the mean amount of rainfall for the 28 days. Give your answer to 1 decimal place, okay, 1 decimal place there. So I'm going to be strict on this one, okay, if you're going to supply an answer. So who can give me that answer to 1 decimal place? Should be a fairly quick one. Okay. Budney's coming in with an answer. Loads of zeros in front of that decimal point, 0.53. We've got James with 4.0. Anybody else offering anything? Okay, 0.54 coming in. Sarah 0.9, okay. Interesting answers here. We've got some range of answers, so anybody going to back any of them up? Lucy with her answer. Okay, right. Jasmine with 3.9, interesting. Okay, so we better rush on now, okay. The answer is in fact 4.0, okay, not 4. 4.0, okay. Let's show you why. Very easy one. I've answered it in one line, okay, basically. The mean, as I'm sure you all know, is to total up all your values and divide by how many you've got. The thing is, if you total up these values up here for that each day of the week there, then you've got to use the total that came from here. And the total would be 21 days times 4.3. Okay? I've added that on and divided by the number of days, 28. You end up with 110.8 over 28, giving you 3.957 and so on. Rounded to 1 decimal place, it is 4.0. Okay? Don't make that mistake of just saying it's 4. Okay? Right. Okay, so let's just come back on. Okay, so there you go. The end of another workout. This is Good Friday here in the UK and that. So I will be back on the Tuesday. Wednesday will be pure. Thursday stats. And Friday back on pure. Okay, so thanks to all of you for coming on and supporting the work that I do. It's great to have that support, knowing that I'm at least teaching a few of you. Okay, so do spread the word if you can. It would be good to see how many we can get on next week. Thank you to Michael once again for helping out on the chat line. Michael from Air Maths Tuition. And yeah, have a good weekend. Have a good break. Stay safe in these difficult times. And see you on Tuesday, hopefully. Okay, bye for now. Bye.